Here we have a question from Bohr model of atom. We are asked to find the velocity of electron in its lowest orbit in the case of a hydrogen atom in terms of fine structure constant alpha. So the velocity of electron of hydrogen atom or hydrogen like ion in the nth orbit, it is given by V is equal to Z E square upon 4 pi epsilon naught n h cross. This is the velocity of electron in the nth orbit for a hydrogen atom or hydrogen like ion. If you don't remember this formula, how will you develop the formula for this? That you can do by considering the radial equation of motion. Fr is equal to mar. Force radial is equal to mass times radial acceleration. Here radial force is the Coulombic force between the electron and the nucleus, and it is equal to minus 1 by 4 pi epsilon naught Ze. This is the charge of nucleus times charge of electron divided by distance square, r square. And the minus sign here is because the force is radially inward, and this is equal to m times acceleration. Radial acceleration is minus v square by r. Here also there is a negative sign because the radial acceleration is also radially inward. So from here we have v square is equal to Z E square upon 4 pi epsilon naught mr. This implies v square is equal to v is equal to Z E square upon 4 pi epsilon naught mvr. Now one of the postulates in Bohr model is that the angular momentum is quantized. Angular momentum mvr is equal to n h cross. The angular momentum is quantized. This is one of the basic postulates of Bohr model. So if we put mvr is equal to nh cross, this is second equation. In the first equation, v is equal to Z E square upon 4 pi epsilon naught mvr. Then we get v is equal to Z E square upon 4 pi epsilon naught nh cross. Now once you get velocity, you can find the kinetic energy by using 1 by 2 mv square, half mv square. You can use this relation and put, instead of v you can substitute this relation. You can substitute a in kinetic energy relation, and once you get kinetic energy, you will get a total energy. Kinetic energy is related to total energy in the case of hydrogen atom by the relation kinetic energy is equal to minus of total energy. So kinetic energy is positive and total energy is negative. Apart from that, the value of kinetic energy and the magnitude of kinetic energy and total energy are equal. They differ by a negative sign. And potential energy, it is related to total energy as PE is equal to 2E. Potential energy is equal to 2 times total energy. So once you know the formula for velocity, you can find all the other relations like kinetic energy and potential energy, total energy, etc. And how will you find the radius of the orbit? Radius is equal to, you can use the relation mvr is equal to nh cross. mvr is equal to nh cross. This implies m times v is Z E square upon 4 pi epsilon naught nh cross times r. This is equal to nh cross. This implies r is equal to n square h bar square 4 pi epsilon naught divided by mze square. Now let us come back to the question. In this question it is asked the velocity in the lowest orbit for hydrogen atom in terms of fine structure constant. So V is equal to, in the case of hydrogen atom, Z is equal to 1, and in the lowest orbit n is equal to 1. So we have E square divided by 4 pi epsilon naught h cross. This is the velocity in lowest orbit for hydrogen atom. This is equal to E square upon 4 pi epsilon naught h cross c multiplied by c. So I am multiplying and dividing by c, and this term here, E square by 4 pi epsilon naught h cross c, this is called fine structure constant. So we can write V is equal to alpha c, and fine structure constant, its value is approximately 1 by 137, and this is a dimensionless constant. There are no units for fine structure constant. So the correct option here is option D. Velocity of electron in its lowest orbit is alpha c.